Hi, let me tell you about another great Manning book, Build a Multi-Agent System from Scratch, with MCP and A2A, written by Val Andrei Fajardo.
Ask a language model where to find the best value croissants in New York City, and it can describe a sensible plan. But the model does not actually search, calculate, click, or verify. It generates text that expresses intent. An LLM agent supplies the system that turns intent into action. LLM agents are useful when a task requires action beyond one text response. They support report generation, search, agentic RAG, coding, and computer use. Each case pairs language generation with tools and orchestration. Multi-agent systems, MAS, extends these uses by assigning subtasks to focused agents. An LLM alone cannot perform tasks. It only generates text. While it can plan and request tools, it cannot execute them. An LLM agent fixes this. It combines the LLM with tools and an execution loop to operate autonomously. Planning and tool calling are the key model capabilities. Planning sets and revises steps. Tool calling selects a tool, fills parameters, and emits a structured request, often as JSON. A weak planner or unreliable tool caller makes a weak agent backbone. The processing loop is where the agent works. A task arrives, the agent plans, calls tools when needed, receives results, updates progress, and continues. The plan is not fixed at the start. It adapts as evidence comes in. Practical agents need enhancements. Memory stores earlier execution details and loads relevant pieces into the future context. Human-in-the-loop design adds review at critical points. It can prevent cascading errors, but it also pauses execution. 3 protocols shape the ecosystem. Model Context Protocol standardizes access to third-party tools and resources. Agent Skills standardizes reusable workflows around a skill.md file. Agent-to-Agent Protocol standardizes communication between agents built with different frameworks. LLM agents are not reinforcement learning agents. RL agents learn policies through environments, actions, and rewards. LLM agents repurpose pre-trained language models to generate plans, actions, and tool calls from task state. A multi-agent system combines multiple LLM agents to collaborate on a broader task. Multi-agent systems work best when the task decomposes cleanly, and specialized agents outperform one general-purpose agent on the smaller pieces. Existing frameworks simplify agent applications, but they hide the machinery. Loops, memory, tools, MCP support, skills support, and coordination logic. The build here goes under the hood through LLM agents from scratch, an educational framework optimized for understanding. The framework is modular. The base module defines tool and LLM interfaces. Tools and LLMs hold implementations. The agent module contains the agent class, loop, and coordination logic. The skills module supports agent skills, while data structures represents tasks, tool calls, and results. The repository is built for hands-on learning. Code listings are framework source code. Code snippets are usage examples collected in notebooks. Additional examples and capstone projects guide you through extending the framework into larger production-scale scenarios. UML diagrams bring clarity to implementation plans. While class diagrams illustrate system structure, sequence diagrams map out behavior over time, such as an agent executing a tool call and receiving a response. The build plan unfolds in 3 sequential phases. First, we establish the foundational infrastructure, which includes the tool and LLM interfaces, an Llama-backed LLM, the LLM agent class, and the core processing loop. Next, we integrate MCP tools, agent skills, memory management, and a human-in-the-loop review mechanism. Finally, we scale from a single agent to full multi-agent systems, MAS, by implementing coordination logic and supporting Google's agent-to-agent A2A protocol.
Get this book at manning.com